So, welcome everybody. Uh, Thank you for stopping by, and today we are finally going to convert our crufty build system of build.h into build.zig, the standard Zig build system. And but before I do, I just want to give an overview of what I've done so far. I did figure out the build issue that I was having last time for the new calculator app, which doesn't do anything right now. But what I'm doing right now in the build.sh is I literally go into all the apps and then like build it, and it's just like kind of untenable at this point. And so I feel like it's kind of time to kind of neaten this up, and let's start on writing our build.zig. So I got this working. If you're curious to see the build.zig for the new calculator app, calculator build.zig. In the YouTube video, I actually gave the solution. This is my solution so far. I don't know if this is the proper way to handle errors in the build.zig, but this is what I do. During the video, I was hoping that there would be a way to parse something like this, and it turns out there is, so that's good. And so I set the target, and then what I do here actually is I compile it into an elf. .elf, which is the standard. I use freestanding, which by default generates an elf file, and then I use object copy to create a bin file. This is not great. I mean, I do the same thing with the kernel.elf, but eventually we're going to write an elf loader to actually parse out all the data needed and allocate the right space and stuff. So eventually we're going to write an elf loader. Whether elf is actually going to be the executable format of this operating system remains to be seen, but elf is the easiest thing to get started with because all the tools are there for that, at least. So right now, this generates calculator.bin, and then in kernel.zig, I actually just embed the file, and I don't do anything with it right now. I just kind of print out the length just to make sure it's a non-zero binary. So yeah. So ideally what I would do is load this data into, allocate enough memory, and then load this data into, well, actually it's already, I don't think I need to allocate any memory. I can just jump into it. So I would basically set up the page tables required for this, and then jump into the first byte of memory into here. Do a sysret system call. Yeah, sysret is the system call to return from kernel mode to user space, and then syscall goes to kernel space. So yeah, but there's a lot more things that you have to do before you even get to that. You have to set up something called the TSS, and like a bunch of other things to like set up the state I think you also need like a GDT entry and like and stuff like that. So there's a bunch of setup you need to do before you even can call sysret. So yeah. But we are not doing that today. Today we are going to change over the build system. So let's take a look at how long it takes to build everything from scratch for release mode and for debug mode. And actually, maybe we should put this into to do txt and factoring graphics. Maybe we can have like build system. Currently using build.h, sh, and then so let's take a look. Let's remove zig cache. And actually, let me see here. Build.sh. So I have a build folder, and so I have a clean. All right, yeah. So let's do a build.sh.clean, and then what we're going to do is time build.sh. So this is the debug build. So let's see how long this takes. 8.7 seconds. I mean, that's really high. Though, interestingly enough, that is actually very low compared to other operating systems. But for us, I will consider that pretty high. So let's go back into to do .txt, and then let's debug build takes about 8.7 seconds from clean, and then let's do release. I forgot to I keep forgetting to hit put time next to it. Wow, that took 27 seconds. Insane. Release build is 27 seconds. Okay. So let us start then. I guess we will use the build.zig from the apps, from the calculator app. So let's do that. Do here is CP apps calculator build.zig, and then And then ideally, the calculator app wouldn't even have a build.zig. Like it would just incorporate it here. So, right, so build.zig. Here we go. So cross. All right. So my build.sh. And also, one of the reasons I wanted to do this is really before my build.sh becomes really, like, it's already pretty unwieldy right now. But I just kind of wanted to do this before this gets a little bit too much. So, yeah. So there's a bunch of targets here. Obviously clean, test doesn't really work right now. I have to fix the test. I'm very not great when it comes to that, but I have to be better with that. As a bootloader, this prints out like the assembly for the bootloader. This prints out the assembly. And then this prints out the assembly for the release. These are very handy tools, and I hope, like, some of this stuff I hope that build.zig can support, because I mean having a shell script is useful for like things like this. But yeah, so here we have, like, we can have b.step. So steps, that seems to create a target here, or a step. So I'm guessing, when run is specified, it looks at the first argument here. Yeah, so let's bring this over here. Let's bring build.sh over here. And another thing I want to bring over here is the actual build.zig here. And then this contains the actual builder. So, yeah. So one of the things I wanted to look at here is b.step. So if we look for the step function, we have the name and the description. I'm guessing like this is the argument to build. One of the things I actually want to do here is zig build, or zig like help build or something like that. Build project. Is there? Like, is there zig big build help? Yeah, cannot, because it does not exist. Okay. To prefix path. Yeah, so there's like not like, so clean is something I have to like manually put in and stuff like that. So what's good actually is I don't think I need to specify a release target and a debug target, because that's already I can already have that. That's already kind of built in here. I think it's actually built into the standard release options. Yeah, standard release for allowing the person running zig build to select between debug, release safe, release fast, and release small. In fact, can we look for this? Release small. Option. Yeah, release safe. So I guess, if we look here, oh, it's a bool, yeah, and then if release safe, and then not. Okay. Or else false. Okay, yeah. So you have to equals true. You have to do -d equals true or something like that. All right. Okay. So if that becomes a little bit too annoying, we'll create more targets, but I don't think that's necessary right now. Now, is there a way to fail or something like that, or error or something like that? Really wish there were some examples. Alright, let's not worry too much about that. Because I can sit here all day and try and, go through this like I did last time and not be able to find the option to do whatever I need to do. I just feel I have enough knowledge to actually at least attempt to do this. Add install raw, push installed file. Okay. Wonder, does this actually? Yeah, I'm not sure. Find program. Okay. Alright, so one of the things, so it's important to note, the main thing of the way the operating system is currently divided is that there is a bootloader, which is one binary, and then there's the kernel, which is another binary. The bootloader actually just does an embed file on the kernel. So here it does it from disassembly build/disassembly.bin, right? I have to figure out how I'm going to do that. I hope this might be tricky. So one of the things is we need to compile the kernel first. We need to run this disassembly.bin. I'm sorry, disassembly.bin is something different. This is where the debug symbols live. Kernel, the actual kernel executable, or the kernel, here we go, this is it, build/kernel.bin. So this is the kernel image. And we need to compile the kernel first, and then also run the debug symbol generator, which generates this file first, and then we can compile the UEFI bootloader. Okay. So, all right. So the first thing is, all right. So let's actually start trying to do something. the first thing is we need to. First thing to probably do here is actually probably run the. What do I need to do? The first thing actually we need to do is compile the kernel image. So in order to do that, we add an executable, which will be kernel.elf. And this will be actually. So we have some assembly files and we have a C file. So you know how I have like source/main.zig. We'll keep that. We won't have a source directory yet for this first iteration. So this main.zig is actually, I think, kernel.zig. So if we go back to the bootloader, the build.sh, you will see, actually do a couple things. So this is where we compile the kernel. First we compile the apps. So first we actually, maybe we want calculator.elf, and then this will be apps calculator, and this will be calculator.elf. We set the target, build mode, and then we install it. And then, so this is the apps. And then what we want here, then we have the bin path. Okay, then this converts it from an elf to a bin. Actually, there's a couple of options I need here. I learned today that obj_copy does not actually allocate the BSS into the flat binary image file unless you give it something to put it in. So, like, if you you have to manually specify the data to populate BSS with. And I just kind of took this from a Stack Overflow or some mailing list answer, honestly. I think what this does is it populates BSS with the data from these things, these sections. I really should look more into exactly what this does, but regardless, I actually don't really care that much because this will be going away at some point, and then we'll just use the elf loader to we won't need to create this, then we'll just use the elf loader. We'll write an elf loader to load this into memory. Once we have an elf loader, then we'll need to allocate space and then put the image in and stuff like that. Though honestly, it would, maybe I could have the elf loader in here. That would be interesting, right? The build script, because that would save time. Honestly, that would save time for running an application. You wouldn't actually have to load the binary. You would just have the flat. I mean, the only thing that you would load is the flat image, and then that's it. But no, you really want an executable format because you need to have things like specifying how big the stack is and stuff like that. So, yeah. But anyway, so this is what I have. This creates all the stuff, creates the calculator binary. which is not a calculator yet. It doesn't do anything yet. Now, so I think what this does is this makes the object copy command run last, which is totally fine. Yeah, okay. I'm a little bit confused by this, because this kind of implies to me that this is an answer from Discord, and I'm a little bit confused by this because this implies to me that the default step, which is this, I guess the main step, what is actually building everything, it's saying that it seems to me that it would call this first and then call the default step, but maybe I'm misunderstanding what default step is. So let's take a look. So what is default step? Self.default step is install TLS step. Oh, top level step, not the TLS security protocol. Alright, so install TLS. So this is the very last thing it does, I guess. Okay, top level step is the very last thing, I guess. So what this is saying is that the install step depends on the... So the install step depends on the obj copy step. But wouldn't that imply that the obj copy needs to be run first before it installs? So this wouldn't exist before object. I don't understand how this works, honestly. So I'm just gonna keep it as is. I think, but it works. I just don't understand how. Okay. All right. So the next thing we need to do is, so I'm hoping that. This is kind of complicated because this needs to happen before we get to actually compiling the kernel, right? So this can't, because I don't fully understand how this works. This doesn't make sense to me. I'm not sure how I'm gonna have to figure out how to fit in compiling the kernel here. What is, alright, so let's look at depend on, right? So self.dependencies append. So what that means is that the top level step, so the install step depends on the obj copy. But the obj copy really depends on install. The install has to be there. So maybe, does this go in the reverse order or something like that? But that doesn't make sense. It's not consistent with the other stuff. So here, right? When we say depend on, so let's take a look at depend on, right? Like the run step depends on the install step. Like this makes more sense to me. This says that you have to install this first, and then you can run it, right? But this says the opposite to me. Hell, this is probably like b.get install step. This is probably the same thing, right? Like it's the same thing, I think. Let's see. Yeah, install TLS. Install TLS.step. It's the same thing. All right. Actually, so if we do, let's test that out, right? If we go to build.zig in the apps, we go here, and then instead of default step, this is get install step. And then let's do sh. Oops. We can even remove the calculator zig cache just to make sure. So if we go into apps, calculator zig cache, and go to bin. Alright, so it didn't generate a bin file, but if we do default step, okay, so that didn't work either. This worked before. It's definitely worked before. Oh, you know what? I'm sorry. It's not in bin. It's here. It's in the. That's why. Oops. Remove calculator.bin. That's why. And then we'll remove the zig cache. And then we'll change this to get install step. And then we will regenerate. Alright, so it did generate calculator.bin, it looks valid. Okay. So let's remove that. So that's like, if I invert this, right, this won't work. I think I've tried this. This does not work. Obj copy command dot depend on b dot get install step. Like, this does not work. Step, I think. Oh wait. Whoops. Thought I had it right the first time. Obj copy command dot step. Yeah, something like that. So that, yeah, so that doesn't work, right? It doesn't do anything, which is strange to me. I probably need to ask more about this on the Discord, because I don't fully understand why this works, or why it's opposite. It's counterintuitive. If we go to, like, if we look at self.dependencies, something like that, or we can go to step.dependencies. Yeah, I don't understand this. Alright, yeah, let me get out of this. But it's good to know that get install step is the same as default step here. Okay. So somehow, so this install step, actually, wait, maybe I'm reading this wrong. So let's take a look at the example here. So run step, so the actual thing, I'm just trying to understand what depend on means. So run step depends on run command, and then run command depends on the install step. So the install step, so what this says is that the install step runs first and then this. This, if we're following the same pattern, that means that run command runs first and then the install step. And then, though maybe, like maybe it runs before it installs. But that doesn't make sense, right? Why would you run it before you install it? Like, let's take a look at exe.run. So we create a run step. So VC package. So is VC package is VC package not the install path? Like, I don't even know what VC stands for. There's a lot of unknowns here. So VC. Oops. Root equals. No idea what this means. Alright, let's get back. Alright, let's try and make the best of this. So let's just continue on and, hope for the best. So let's just assume that this did what I wanted it to do, and it output calculator.bin. Honestly, what, maybe I do want this. Hold on. Before it was just outputting it into the directory, which is probably not what I want. And then, oh wait, I'm in the wrong one. But still, actually, you know what? This is still what I want anyway. Regardless. Alright, so this is S, and then this is the bin path. Let's get out of this before we confuse ourselves even more. Alright, so let's just assume it ran this, I guess. So now we're going to try and compile the kernel. So if we do let's do one of these. Kernel elf. And then what's nice about this is we can kind of generalize this. Like, you know, we'll do a maybe we can do the same thing in Bash, but hopefully we can like do an ls here, I guess, and then see what's in this directory, or somehow figure out the contents of this directory and then loop through it and then just kind of generate these programmatically. Alright, so this is kernel.elf. Kernel.bin. So actually, let's scope this. Let's try and run this and see if this actually does something. Zig build. Okay, unable to find calculator. Okay, sure. So so it said, so let's do zig cache bin. I should probably customize the bin directory. That worked. Okay. Interesting. Alright. Well, this didn't seem to work. But we got something at least. Sometimes it's necessary to just stop complaining and just like start trying to do it. But this does not, this I need to kind of figure out what's happening here. So let's take a look at the build script for the kernel. So we compile the C. So here's the problem. So we have some assembly here. So C is not a problem. Assembly is kind of unfortunate here. Though, I mean, whatever, I guess. So another thing is like the AVX stuff. So we need to kind of have that flag as well. But let's not worry about that right this second. So there should be a way. So a couple of things we need to do. First, we need to add a C file. So we add a executable. Now, can we add like a C source file? Is there like add C source or something? Okay, sure. Okay, good. Lib exe opt step. So let's do that. So we're going to do exe.add C source file, and then this will be bridge.c. C, and then these are all the flags. So this is the include flag. So also I need to define what bin is, I guess. Can I actually get... actually, you know what? It should be a built-in thing to get the include, maybe. Like, I feel that should be built-in. To get, like, the include path. Source, like if we do zig env, right? What we care about is the lib directory, I believe. So if we go to build.sh, yeah, it's lib.zig include. So yeah, it's this directory right here. So what is the libdir? Like libdir or libdir. Or is there like an env or something like that? Alright, let's take a look. So we'll take a look at env. Make it like or let's do libdir. Print env. This is it. So standard lib directory. Here we go. Introspect Oh, so there's an introspect.zig. Is that a new thing? Yeah, because I don't have that. I have a feeling that that is a new thing. Alright, let's take a look at build.zig. Libdir. Okay, so maybe there is a... Okay, so it's attached to the builder, I guess? So, before we do this, let's just print it out. Print, libdir, and then this will be b dot... What was it again? b dot libdir. Oh, whoops. Okay, so let's see what happens here. So what's in zig cache lib? Nothing. Okay, so this is, yeah, this is not what I'm looking for. Yeah, I thought it would be a little weird to have it in the builder. But it looks like introspect is what I want, but that looks like a new thing. So let's take a look here. Like, let's take a look at this one. Or not. History. Oh no, there is something called introspect. Oh, it's in the zig source. Okay. Yeah, no, that's not what. Okay, so this is not accessible, but like find lib. Now if we go into introspect. Okay, so we have FS, the file system. Okay, the self exe path alloc. Then find So it has something to do with this. Both the directory handle. It would be nice if this was actually part of the library. All right, let's do this. Or like just catch this. This will be the allocator. Alright, so let's try this. I hate this. Like const path. But like, even it's frustrating because this, I think even this won't work. Like, this is like super annoying. Yeah, no, I can't. Like, it's like super annoying because I have to do something like this. It just like doesn't. I don't fully understand why this doesn't work. I think maybe this. Oh, I think this like returns a non-const, and then that, and the catch returns a const or something like that. Yeah, so it like this returns like a modifiable string, and then but like this is a non-modifiable string. That's why. So it's different, but what are you gonna do? That makes sense. All right, so. So this is wrong. That's not what I want. Because this is just getting it from the zig. So is there really no way? Is this like not exposed to me in any way? I find that hard to believe. Like, just Google zig library path. This is not what I'm looking for. There has to. I find it hard to believe. It's the same thing with the other thing. Like, I find it hard to believe that there wouldn't be some sort of way of getting the library directory. Okay. so actually I probably do need to head out in a couple minutes, but before I do, let me make some notes. I'll have to ask all this on Discord, but to do. So, build system, ask how depend on works. Ask ask if there is a way of getting the library directory path from the standard library. So yeah, so I have that. Let's check one more time. Path. Just check one more time. Paths.libders. IT only arg. Well, this is just if it's passed in. If we're trying to override it, which we're not, we're just trying to figure out where to get it. All right, Zig library directory. No, introspect dot. All right, so we're gonna have to so the problem is that it kind of cheats here a little bit and just takes the directory. Hold on, lib directory, libdir, yeah, zig lib directory dot path, and then it gets this from introspect, and then introspect depends on getting the path of the actual zig compiler and the way it does that is because that's the running executable. It just gets the path of the running executable, which happens to be the zig compiler, and so it can get the zig library directory from that. Though I guess the way to not to actually get around that is actually to use the override flag, and so we'll have our own directory for the library, which I guess makes sense because we're storing everything in the repository anyway. So okay, so that means that we have to. I guess the thing is that we can't. We have to kind of do this magic that we're doing here in the bash script, which is we just take the directory name of what we're running in and then append third party, and then if we're on Mac or Linux, depending on that. So we have to really just do this, which I guess is unfortunate. It'd be nice if there was actually a thing in the standard library to just pull that down. But though maybe that's a slightly good thing. I don't know. Whatever. But yeah, I'll ask on the Discord if there's something in the standard library to do this. But I doubt it, since it looks like the Zig source code doesn't leverage anything like that. So I doubt it's there. But whatchamacallit? So then I'll have to do this stuff, which I guess is not terrible, but whatever. All right, so I think I have to head out now. I might stream tomorrow if I could get my my questions answered. So thanks guys for coming out, and I will see you hopefully tomorrow.